Magnetic field lines form closed loop, whereas electrostatic field lines cannot form closed loop. Pole strength is directly proportional to area. Area and pole strength is directly proportional. Magnetic moment is equal to Qm, which is the pole strength, into L. Qm is the pole strength, L is the magnetic length. What is the direction of magnetic moment? It is from south to north. Cutting of a magnet, cutting longitudinally cut ചെയ്യുമ്പോൾ area എന്താവും? Area becomes A by N. N is the number of times cutting, and area is directly proportional to Qm, or the pole strength, and Qm is directly proportional to magnetic moment. So if area becomes A by N, then magnetic moment, new magnetic moments become old magnetic moment divided by N. Cutting perpendicular to the length becomes L by N, and Qm is again proportional to L, therefore M dash becomes M by N. Bending of magnets, then length becomes effective length. Effective length in this case is the hypotenuse. Hypotenuse is equal to root of L square plus L by 2 square plus L by 2 square, and magnetic moment is Qm into L effective. In case of an arc like this, then L effective is 2r sin theta by 2. 2 into r into sin theta by 2. R is the length of the vector application. Resultant magnetic moment, രണ്ട് m1 m2 magnetic moment. Resultant magnetic moment is equal to m1 plus vector m2, that is m is equal to root of m1 square plus m2 square plus 2 m1 m2 cos theta. Direction is given by tan phi. It is m2 sin theta divided by m1 plus m2 cos theta, random m2. Equal vectors 2m cos theta by 2. Magnetic field due to magnetic monopole, it is equal to mu 0 by 4 pi into Qm divided by r square. Magnetic force on magnetic monopole, electric force is Q into E. So this Q is substituted as Qm pole strength, and E is substituted as B for the magnetic field. Magnetic field of a bar magnet along an axis, it is equal to mu 0 by 4 pi 2 mr divided by r square minus L square the whole square. R square minus L square the whole square. Along the equatorial line, it is mu 0 by 4 pi m divided by r square plus L square the whole divided by 3 by 2. Short dipole, axial is 2m by r cube into mu 0 by 4 pi. Equatorial is m by r cube into mu 0 by 4 pi. Axial is 2 times b equatorial, or b axial is negative 2 times b equatorial. At any general point, it is mu 0 by 4 pi into m into root of 3 cos square theta plus 1 by r cube. Dipole in a uniform magnetic field, net force is 0. Tau is equal to m into b, or mb sin theta. Work done to rotate from theta 1 to theta 2 is mb into cos theta 1 minus cos theta 2. Potential energy is negative mb cos theta. Theta 0 means it is minimum, it is stable equilibrium. Theta 180 means it is maximum, that is minus 1. Cos 180 is minus 1, so it will become maximum. Minus mb sin mb cos theta, minus mb cos theta, minus mb cos theta. Theta 180 means it is minus 1, so this becomes positive, and it is umax and unstable equilibrium. Oscillation and SHM. Oscillation T, torque proportional to negative of theta. This is the condition for SHM. Time period is equal to 2 pi omega, or it is 2 pi into root of I by mb, 2 pi root of I by mb. Magnetic flux. magnetic flux is equal to BA cos theta. Theta is the angle made by B with the A. If alpha is the angle made by magnetic field with the plane of the coil, then theta is 90 minus alpha. Closed surface integral B dot ds is 0, whereas E dot ds is 1 by epsilon 0 times Q enclosed. Time period ഇങ്ങനെ രണ്ടെണ്ണം എടുത്ത് വെച്ചിരിക്കുന്ന ടൈമിൽ what is the time period? Time period is 2 pi root of I by mb. Here it is I becomes I1 plus I2 and mb becomes m1 plus m2 into b. H is equal to b by mu. H is the field that causes magnetization. Magnetic field and density is H. H is b by mu. For a solenoid, H is equal to b by mu and H is equal to mu Ni. Therefore, H is equal to Ni. Very important relation. H is equal to Ni. Root of H is ampere meter inverse. Intensity of magnetization. This is magnetic field intensity, and what is intensity of magnetization? It is I is equal to magnetic moment by volume, becomes Qm by A. Magnetic susceptibility is I divided by H, that is intensity of magnetization divided by magnetic intensity. Relation between permeability and susceptibility. Relative permeability is 1 plus susceptibility, and magnetic field B is equal to mu 0 into H plus I. Magnetic moment due to orbital motion of an electron. Magnetic moment is equal to EVR by 2. Angular magnetic moment is equal to MVR. Our ratio, it is gyromagnetic ratio. M is equal to EH by 4 pi m. It is Bohr magneton when N is equal to 1 in case of hydrogen. Magnetic substance: diamagnetic, paramagnetic, ferromagnetic. Paramagnetic and ferromagnetic aligns parallel to field, whereas diamagnetic allows perpendicular to the field. ഒരു ഡയാമാഗ്നറ്റിക് സബ്സ്റ്റൻസ് മാഗ്നറ്റിക് ഫീൽഡിൽ വെച്ചാൽ there is little or there is no field lines passing through it. എല്ലാം ഇങ്ങനെ ഡീവിയേറ്റ് ചെയ്ത് പോത്തേ ഉള്ളൂ. its I value is very low. There is unpaired of electrons in paramagnetic. In ferromagnetic also there is unpaired of electrons. Very important is domain formation in ferromagnetic substance. Ferromagnetic substance, there is domain formation. In case of ferromagnetic, it moves from weaker field to stronger field, whereas in diamagnetic it is stronger field to weaker field. In case of diamagnetic, chi is negative. In paramagnetic, chi is small and positive. In ferromagnetic, chi is large and positive. Relative permeability is less than 1 in case of diamagnetic. Relative permeability is more than 1 in case of paramagnetic. Paramagnetic is weaker and attractive. Ferromagnetic is stronger and attractive. Ferromagnetic substance allow maximum field lines to cross through it, whereas paramagnetic allow only 1 or 2 field lines, whereas diamagnetic allows no field lines. They align perpendicular to the field. They align perpendicular to the field so that no field line passes through them. Arranged in the direction of field. Paramagnetic is arranged in the direction of field. Diamagnetic allows maximum number of field lines.